Compound interest. This is where the math starts to really take a role in the real world in terms of finance. So to find compound interest, we have a formula that says A of t, where t is time, equals A naught times 1 plus r divided by k all to the power of kt, where A naught is the amount invested. This is your initial condition. So say you invest $100, $1,000. R is the interest rate, which is usually about 1% or 2%. It's always in decimal form. K is the number of times per year you compound it. So if you compound it once, it would be 1. If you compound it 12 times in a year, it'd be 12, and so on. And T is years. So if something is compounded continuously, that means that the interest is always changing. So the idea is we're letting K approach infinity, so it's being compounded infinitely many times per year. So not only are you compounding maybe once a year, not twice a year, not every month, not every day, not every minute, not every second, not every nanosecond, but even smaller than that. The interest is always being compounded. And so we can represent that by a differential equation. So we get the differential equation is equal to the change in the amount with respect to time is equal to R times A, where R is the rate and A is the amount. So this is saying that our amount's going to change because we're multiplying by a number, and then the dA is the change in the amount, and the dt represents the change in time, where our initial condition is A of 0 is equal to A naught. So at time 0, we have some fixed number. So we're going to use all of this information in order to determine the differential equation for compounding continuously. So we have dA over dt is equal to RA. So we want all of our A's on one side and all the T's on the other. So we multiply both sides by dt and divide both sides by A. So times 1 over A. And you're going to get 1 over A dA is equal to R dt. This should look very familiar to the example we just did in the previous video. So now we're going to integrate both sides. So when you integrate 1 over A, you get ln of A. And A is positive because you can't invest a negative amount, so you don't need the absolute value bars, equals R times T plus C. And so from here, we need to raise both sides to the E to get rid of the ln. So we're going to get A is equal to E to the RT plus C. So A is equal to E to the RT times E to the C. And we're going to call E to the C A naught. Again, you can call it C if you want, times E to the RT. And so A in times of T is A naught times E to the RT. So this is a differential equation that allows us to, at any given time in years, determine how much money we've accumulated. So in example 2, you deposit $800 at 6.3% initially. The word initially applies to the $800. The interest rate will not change. How much will be in the account 8 years later if it's compounded continuously or compounded quarterly? And if you don't know what quarterly means, this means 4 times in a year. So what I want you to do right now is on your own, try to determine both of these. A, if you compound continuously, and then B, if you compound only quarterly. All right, so let's see what we get. So if we compound continuously, I'm going to do part A first. So this is compounding continuously. Well, we know, let's just start identifying some of our information. We know that A naught is going to be 800 because you invest $800. R is 6.3%, but we need that in a decimal, so it's 0.63. And our t is equal to 8 because we compound over 8 years. So it's pretty simple. All we have to do is plug it into a formula. You get a of t is equal to a naught e to the rt, which is going to be 800 e to the 0.063 times 8. And when you put that in a calculator, you're going to get 1,324.26 because we're dealing with money, so we only go 2 decimal places. So if we put $800 in at 6.3%, in 8 years, we'll have about $1,300 in the bank. So now let's try it where we compound quarterly. So this is quarterly. And the formula, if you're not compounding continuously, is a of t is equal to a naught 1 plus r over k to the kt. So we put 800 times 1 plus 0.063 over 4, and then 4 times 8. You put that in a calculator, and you're going to get 1319.07. So as you can see, compounding continuously will yield a greater number. Now typically with investments, people will invest thousands and thousands of dollars, which will make the interest rate build on it faster, which will give you a higher yield.